Welcome to Milky Narratives. Leave behind the distractions of the waking world, settle into a moment of calm, and join me on a peaceful voyage through the universe. Tonight's story begins where light fades and wonder begins. 1. The places where sunlight never arrived. What if there are places in the universe that have never seen a sunrise? Not a sunrise hidden behind clouds. Not a world trapped beneath a thick atmosphere. Not a distant planet enduring a long polar night. But regions of space that have existed for billions of years without ever being touched by the light of a single star. Tonight, as you settle in and let your thoughts drift beyond Earth, I want to take you somewhere strange, somewhere so dark that even our imagination struggles to picture it. Because when most of us think about the universe, we imagine stars, countless stars, glittering galaxies, brilliant nebulae glowing with color, the dazzling rivers of light that stretch across the night sky. But here's the surprising truth. The universe is not mostly light. It's mostly darkness. An ocean of darkness so vast that every star you've ever seen, every galaxy ever photographed, every glowing object discovered by every telescope in human history occupies only a tiny fraction of the cosmic landscape. And hidden within that darkness may be places where sunlight, or any starlight at all, never arrived. To understand how such places can exist, we first need to appreciate just how empty the universe really is. Imagine shrinking our entire solar system down to the size of a coin. On that scale, the nearest star would still be hundreds of kilometers away. The stars that look crowded together in the night sky are actually separated by unimaginable distances. Galaxies themselves are even lonelier. The Milky Way contains hundreds of billions of stars, yet most of the space between them is almost completely empty. And between galaxies lies something even more astonishing: the cosmic voids. These enormous regions are among the largest structures in the known universe. Despite the name structure, they are defined by what they lack rather than what they contain. Few galaxies, few stars, almost no sources of light. Just immense volumes of near-empty space stretching for hundreds of millions of light years. If an observer somehow found themselves floating inside one of these voids, the universe might appear profoundly different. The familiar bright band of the Milky Way would be gone. Nearby stars would be absent. Entire constellations would never exist. The night sky might appear almost completely black. Not because vision failed, not because darkness covered the heavens, but because there would simply be very little light to see. And some voids are so vast that light from distant galaxies arrives only as faint whispers after journeys lasting billions of years. The universe, it turns out, contains neighborhoods where cosmic loneliness reaches extraordinary extremes. Yet even these giant voids may not represent the darkest places of all, because darkness has a history. Let's travel back to a time before the first stars existed. A time when the universe itself was young. After the Big Bang, the cosmos was filled mostly with hydrogen and helium. There were no galaxies, no planets, no suns, no glowing nebulae. Nothing resembling the night sky we know today. For millions of years, the universe drifted through a period astronomers sometimes call the cosmic dark ages. The name sounds dramatic, but it is surprisingly accurate. During this era, space contained matter. It contained gravity. It contained the ingredients that would eventually create stars and galaxies. But no stars had ignited yet. The universe was dark, completely dark. Imagine existing during that time. No sunrise anywhere, no distant starlight, no galaxies decorating the heavens. Only endless darkness stretching in every direction. For perhaps 100 million years or more, the entire observable universe existed in this strange twilight before the first cosmic lights finally began to appear. In a sense, every star you see tonight is a survivor from the end of those ancient dark ages. Every sunrise on Earth is part of a story that began when the first stars pierced the darkness billions of years ago. Yet darkness never entirely disappeared. Even today, enormous regions remain astonishingly isolated from the cosmic fireworks taking place elsewhere. And then there is another possibility, one that becomes even stranger. What if there are objects wandering through space that never possessed a sun at all? Astronomers believe the galaxy may contain vast numbers of rogue planets. These are worlds that drift freely through interstellar space after being ejected from their planetary systems. Imagine a planet larger than Earth, perhaps covered in ice, perhaps hiding a deep ocean beneath a frozen shell, perhaps carrying an atmosphere thick enough to trap internal heat. Now remove its star, remove every sunrise, remove every sunset, remove every bright day that ever was. For billions of years, that world would travel through darkness, its skies permanently black, its horizons illuminated only by distant stars too faint to provide warmth. A planet without dawn, a planet without seasons, a planet that has never known daylight. And there may be billions of them. Some studies even suggest rogue planets could rival or exceed the number of stars in our galaxy. Entire hidden populations of worlds drifting unseen through the dark. Worlds that rarely reveal themselves because they emit almost no light of their own. If life somehow exists on such a world, it would evolve beneath eternal night. Its oceans would never sparkle beneath the sun. Its creatures would never witness a blue sky. Its civilizations, if they arose, might spend their entire history believing darkness is simply the natural state of existence. The thought is both eerie and strangely beautiful, because it reminds us how unusual our own situation really is. Here on Earth, sunlight feels ordinary. It greets us every morning, warms our skin, paints the clouds, creates sunsets and seasons and rainbows. But in the larger universe, light is precious, rare, localized, fragile. Most of the cosmos exists far from the warmth of stars. Most of reality unfolds in silence and darkness. And perhaps that is what makes light so meaningful. A candle seems brightest in a dark room. A star shines most beautifully against an endless black sky. And our sun, ordinary by cosmic standards, becomes extraordinary simply because it transformed one small world into a place where oceans shimmer, forests grow, and curious minds can wonder about the darkness beyond. As we continue our journey through the hidden regions of the cosmos, we'll discover worlds even stranger than these, places where ancient relics drift through space, where galaxies vanish beyond reach, and where entire chapters of cosmic history remain concealed in the shadows. But for tonight, let your thoughts linger among those silent regions where sunlight never arrived. Vast expanses untouched by dawn, forgotten corners of creation waiting in eternal darkness. And somewhere out there, beyond the glow of every familiar star, the universe continues its quiet journey through the night. 2. The coldest places nature ever created. There is a special kind of silence that exists only in extreme cold. Not the silence of a quiet room, not the stillness of a winter night, but a silence so profound that even the restless dance of atoms begins to slow. A place where motion itself becomes rare, where heat, the invisible energy that animates every molecule around you, nearly disappears, and where reality starts revealing behaviors so strange that they seem more like science fiction than science. As we continue our journey through the hidden regions of the cosmos, we leave behind the dark worlds that never knew sunlight and descend into another extreme realm. The coldest places nature has ever created. Places where temperature approaches an ultimate boundary, a limit built into the laws of physics themselves. A place called absolute zero. Absolute zero sits at minus 273.15 degrees Celsius, or about minus 459.67 degrees Fahrenheit. At this temperature, atoms possess the least possible amount of thermal motion allowed by quantum mechanics. You often hear people say atoms completely stop moving at absolute zero. That isn't quite true. Quantum physics refuses to allow complete stillness. Even at the coldest temperature nature permits, tiny fluctuations remain. Reality never becomes perfectly motionless, but it comes astonishingly close. To understand how cold this really is, imagine removing heat layer by layer from the universe around you. The warmth of a summer day disappears, then the warmth of your body, then the warmth trapped inside stone, ice, and metal. Further and further you descend, until even the tiniest atomic vibrations fade toward silence. What remains is a realm almost impossible for human intuition to grasp. And surprisingly, the universe contains places that come remarkably close. Most people assume outer space itself must be the coldest environment imaginable. After all, space looks dark and empty. Surely it must be frozen beyond belief. But the truth is more interesting. Even the emptiness between galaxies is permeated by the ancient glow of the cosmic microwave background. The faint afterglow left behind by the Big Bang still fills all of space. That ancient radiation keeps the average temperature of the universe at roughly 2.7 degrees above absolute zero, cold beyond human experience. Yet not the coldest place known. Nature found ways to go even lower. One of the strangest examples lies inside a dying star. When stars similar to our sun exhaust their fuel, they leave behind dense remnants known as white dwarfs. At first, these stellar corpses remain incredibly hot. Some shine with temperatures exceeding 100,000 degrees, but over billions and trillions of years, they slowly cool. Their stored heat radiates away into space. Their brilliant glow fades. Eventually, they become dark stellar embers drifting through the galaxy. Astronomers call these hypothetical objects black dwarfs. The fascinating part is that the universe is not yet old enough for a single black dwarf to exist. The cooling process takes longer than the current age of the cosmos. Some of the coldest objects nature will ever create belong not to the present universe, but to its unimaginably distant future. Imagine a star that has spent trillions of years slowly losing its warmth. Not millions, not billions, trillions. Long enough for entire galaxies to transform. Long enough for civilizations to rise and vanish countless times. Long enough for cosmic history itself to feel ancient. Eventually, that stellar remnant may cool to temperatures only a few degrees above absolute zero, a frozen monument to a universe growing older and darker. Yet even these future relics may not represent the ultimate extremes of cold. Because nature has another surprise waiting, one that emerges from the bizarre rules of quantum mechanics. When matter becomes sufficiently cold, atoms stop behaving like individual particles. Their identities begin to blur. Instead of acting separately, they merge into a single collective quantum state. This strange form of matter is known as a Bose-Einstein condensate. It was predicted decades before scientists managed to create one in laboratories. When researchers finally succeeded in 1995, they produced something extraordinary. A substance so cold that millions of atoms effectively began behaving as one giant atom. The boundaries between individuals disappeared. Quantum behavior emerged on scales humans could directly observe. Imagine an entire cloud of atoms moving together like a perfectly synchronized dance troupe. Not because anyone instructed them to, but because the laws of reality itself demanded it. In these bizarre states, matter can flow without friction. Waves of probability replace familiar physical behavior. The distinction between particle and wave becomes increasingly blurred. Reality starts looking less like solid objects and more like mathematics brought to life. And all of it emerges simply because things become incredibly cold. Scientists have created Bose-Einstein condensates, only billionths of a degree above absolute zero. For brief moments, these laboratory experiments produce temperatures colder than almost anywhere naturally known in the universe. Human beings on a tiny planet orbiting an ordinary star manage to create environments colder than most regions of cosmic space. There is something quietly astonishing about that achievement. The universe taught us its rules. Then we learned to push those rules to their limits. Yet perhaps the most hauntingly cold places exist not in laboratories or dying stars, but in immense clouds drifting between the stars themselves. Deep inside molecular clouds, sunlight struggles to penetrate. These vast regions contain the raw ingredients of future solar systems: hydrogen, dust, trace elements forged in ancient stars. Temperatures can fall to only a few degrees above absolute zero. Inside these frozen cosmic nurseries, atoms move slowly enough to assemble delicate molecules. Water forms. Organic compounds emerge. Complex chemistry unfolds in darkness. Ironically, some of the coldest environments in the universe are also places where future stars are born. The deepest cold often becomes the beginning of future warmth, a poetic cycle repeated throughout cosmic history. Stars form, stars shine, stars die. Their remnants cool, new clouds emerge, new stars ignite, and the cycle begins again. But perhaps the coldest natural location ever discovered is even stranger. Far from stars, deep within the constellation Centaurus, lies a remarkable object known as the Boomerang Nebula. This expanding cloud of gas is cooling so rapidly that it has become colder than the cosmic microwave background itself. Its temperature has been measured at roughly 1 degree above absolute zero. Think about that for a moment. The Big Bang left a faint warmth everywhere in the universe. Yet the Boomerang Nebula managed to cool below that universal background temperature. It is effectively colder than space itself, a place where gas expands so quickly that heat drains away at extraordinary rates, a cosmic refrigerator operating on scales beyond imagination. If you could somehow visit this nebula, you would encounter one of nature's most extreme environments, a realm where warmth becomes almost non-existent, a realm where matter approaches the ultimate lower limit permitted by physics. And yet, even here, reality never fully stops. Quantum fluctuations continue, particles flicker, fields vibrate. The universe refuses complete stillness. There is something beautiful about that. No matter how cold the cosmos becomes, no matter how dark the future grows, no matter how close reality drifts towards silence, the universe never becomes entirely motionless. Some tiny whisper always remains, a faint pulse beneath the stillness, a reminder that existence itself is dynamic, that change never fully ends. And as we drift onward through these hidden corners of creation, we begin to discover something unexpected. The universe is not merely a collection of stars and galaxies. It is a landscape of extremes, places of unimaginable darkness, places of impossible cold, places where the familiar rules of everyday life give way to deeper truths. And ahead of us lie regions stranger still, locations where gravity bends reality itself, where ancient relics preserve memories of the first stars, and where the future of the cosmos may already be quietly taking shape in the dark. 3. Worlds floating between the stars. There is a comforting assumption most of us carry without ever thinking about it. Every planet belongs to a star. Every world has a sun rising somewhere above its horizon. Every ocean, mountain, desert, and sky exists under the glow of a parent star that provides warmth, light, and energy. After all, that is the story we know. Earth belongs to the sun. Mars belongs to the sun. Jupiter and Saturn belong to the sun. Even when astronomers discover distant exoplanets orbiting other stars, the pattern seems familiar. A star forms, planets emerge around it. Gravity keeps the family together. But the universe, as it often does, refuses to follow simple expectations. Because not every planet belongs to a sun. Some worlds have been cast out of their systems. Some never settled into stable orbits at all. Some wander alone through the darkness between stars. They drift through the galaxy like cosmic ghosts. No sunrise, no sunset, no parent star lighting their skies. Only endless night. These are the rogue planets, and they may be among the most mysterious worlds in the universe. Imagine standing on a planet that has no sun. Look upward. There is no bright star dominating the sky, no familiar source of warmth, no daily cycle of light and darkness. Instead, the heavens are permanently black. Thousands of stars may still be visible in the distance, sparkling like frozen diamonds against an ocean of darkness. But none of them belong to you. They are impossibly far away, beautiful, untouchable, cold. For a long time, astronomers weren't even sure rogue planets existed in significant numbers. The idea sounded almost tragic. How could an entire planet lose its star? How could a world become so completely alone? The answer begins during the violent birth of planetary systems. Young solar systems are chaotic places. Newborn planets tug on one another gravitationally. Massive gas giants migrate through their systems. Orbits shift, worlds collide. Gravity throws celestial bodies around like billiard balls on a cosmic table. Sometimes a planet receives a gravitational kick powerful enough to escape entirely. Instead of settling into a stable orbit, it is launched into interstellar space, forever, never to return. Imagine Earth suddenly being thrown from the solar system. The sun would gradually shrink behind us, each year becoming fainter, smaller, more distant. Eventually, it would look no brighter than an ordinary star. Then, the long darkness would begin. Fortunately, Earth is not going anywhere, but countless other worlds may have suffered exactly that fate. And modern observations suggest rogue planets might be astonishingly common. Some estimates even propose there could be billions of them in our galaxy alone, perhaps more rogue planets than stars. Think about that for a moment. The Milky Way contains hundreds of billions of stars, yet hidden among them may be an even larger population of wandering worlds, entire planets drifting unseen through the darkness, invisible kingdoms moving silently between the stars. Most are incredibly difficult to detect. After all, planets normally reveal themselves through the light of their stars. Without a nearby sun, rogue planets become almost completely invisible. Astronomers often find them through gravitational microlensing, a remarkable phenomenon predicted by Einstein. When a rogue planet passes in front of a distant star, its gravity briefly bends and magnifies the star's light. The star appears to brighten for a short time, then the effect vanishes, like a shadow passing across a distant lamp. From these subtle clues, astronomers can infer the presence of an otherwise invisible world. It's a little like discovering a whale beneath dark ocean waters by observing the ripples it creates on the surface. You never see the creature directly, only its influence. And every discovery hints that the galaxy may be filled with far more hidden worlds than we once imagined. But perhaps the most fascinating question is not how many rogue planets exist, it's whether some of them might remain habitable. At first glance, the idea seems impossible. Without sunlight, temperatures should plummet. Oceans should freeze solid. Atmospheres should collapse onto the surface as ice. Life should disappear. Yet nature loves exceptions, and the universe is full of surprises. Consider Jupiter's moon Europa, or Saturn's moon Enceladus. Neither receives much sunlight, yet beneath their frozen surfaces lie enormous liquid oceans. These hidden seas survive because internal heat continues flowing from their interiors. Radioactive elements decay deep underground. Tidal forces generate additional warmth. The result is liquid water existing far from the sun's comforting glow. Now imagine a rogue planet, much larger than Earth, a world possessing a thick atmosphere rich in hydrogen. Hydrogen is remarkably effective at trapping heat. Even without starlight, such an atmosphere could act like a giant insulating blanket. Heat escaping from the planet's interior might become trapped. Temperatures could remain surprisingly moderate, perhaps warm enough for liquid water, perhaps warm enough for oceans hidden beneath ice-covered surfaces. And wherever liquid water exists, scientists become interested, because on Earth, water and life seem inseparable companions. Of course, we have no evidence that life exists on rogue planets, but the possibility remains intriguing. Imagine an ocean world drifting through interstellar darkness. A thick shell of ice protects a vast hidden sea. Deep below, hydrothermal vents release heat and minerals. Microbial ecosystems flourish around those vents. Entire biospheres evolve without ever seeing a star. Without sunrise, without daylight, without knowing that stars even exist. Life illuminated only by chemistry and geothermal energy. If such ecosystems exist, they would represent one of the strangest outcomes of cosmic evolution, living worlds completely disconnected from sunlight. Yet rogue planets may offer something even more extraordinary. Time. Stars eventually die. The sun itself will one day expand into a red giant. Earth's long-term future is uncertain. But rogue planets are different. They're no longer tied to stellar evolution. No expanding star threatens them. No supernova waits nearby. No parent sun ages above their skies. In some ways, rogue planets may become long-term survivors of cosmic history. While stars are born and die around them, they simply continue wandering, silent, dark, patient. A rogue planet ejected billions of years ago may still be traveling today, and it may continue drifting for trillions of years into the future. Long after many familiar stars have vanished, long after galaxies themselves begin to change. There is something strangely poetic about that image, a lonely world crossing the darkness between suns, carrying mountains formed beneath ancient skies, carrying oceans perhaps hidden beneath ice, carrying the memory of a solar system that no longer exists. A cosmic refugee preserving fragments of a forgotten past. Perhaps somewhere tonight, beyond the reach of every telescope currently pointed skyward, one of these wandering worlds is crossing the gulf between stars. No sunlight touches its surface. No civilization marks its passage. No observer watches its journey. Yet it continues onward, orbiting nothing, belonging nowhere, and somehow still remaining part of the great story of the cosmos. Because the universe is not merely a collection of bright things, not merely stars and galaxies shining across the night. Much of its beauty exists in hidden places, dark places, silent places, worlds that wander alone through endless space. And as our journey continues, we will discover that some of the universe's greatest mysteries are not found where the light is brightest. They are found where almost no light exists at all. If this journey into the hidden corners of the cosmos is helping you unwind tonight, consider subscribing so we can continue exploring the universe together. 4. The slowest events in the universe. There is a tendency in human life to think of change as something obvious. We watch children grow, cities expand, mountains erode, seasons arrive and depart. Even the stars seem to move across the sky from night to night. Our lives are measured in motion, in transformation, in visible change. But the universe operates on timescales so vast that some of its most extraordinary events appear completely frozen from the human perspective. Entire civilizations could rise and vanish, languages could be born and forgotten, empires could crumble into dust, and some cosmic processes would barely advance by a single step. Tonight, as we continue our journey through the hidden corners of the cosmos, we encounter a different kind of wonder. Not the darkest places, not the coldest worlds, but the slowest events in existence. Processes unfolding so gradually that the universe itself seems to hold its breath. Imagine standing beside a clock that ticks only once every million years. You might wait your entire life and never hear a sound. Yet compared to some cosmic events, even that clock would seem hurried. Let's begin with something surprisingly familiar: the stars. When we look up into the night sky, the constellations appear eternal. The stars seem fixed in place. Ancient civilizations saw Orion. We see Orion. Future generations will see Orion too, at least for a while. But the stars are moving, every single one. The reason the constellations appear unchanged is simply because the motions are incredibly slow. Stars travel through the galaxy at hundreds of thousands of kilometers per hour. Yet they are separated by such enormous distances that noticeable changes require tens of thousands of years. If an observer could compare today's sky with the sky from 100,000 years in the future, the familiar constellations would be almost unrecognizable. The patterns we know would dissolve. New shapes would emerge. The heavens themselves would be redrawn. Yet to us, everything appears perfectly still. It's one of the universe's first great illusions, movement hidden behind immense scales of time. And stars themselves undergo transformations that are even slower. Our sun is approximately 4.6 billion years old. It feels permanent, steady, reliable. But deep within its core, change is occurring every second. Hydrogen atoms fuse into helium. Energy slowly builds. The structure of the star gradually evolves. The sun today is actually brighter than it was when Earth first formed. Yet the increase happens so slowly that no human observer could ever notice it directly. Every century, every millennium, every civilization experiences essentially the same sun. Meanwhile, over billions of years, the star quietly transforms itself. One day, far in the future, it will become a red giant. But from our perspective, that future feels almost motionless. The process unfolds on timescales that dwarf human history, and stars are not the only objects practicing patience. Galaxies may be even slower. The Milky Way is currently rotating. Our solar system is orbiting around the galactic center at roughly 220 kilometers per second. That sounds incredibly fast, yet one complete orbit requires approximately 230 million years. Dinosaurs appeared and vanished during just one circuit around the galaxy. The entire history of humanity occupies only a tiny fraction of our current galactic year. Imagine a clock where one tick represents the rise and fall of entire species. That is the pace at which galaxies move, and galaxies themselves continue evolving. Spiral arms shift. Stars are born, stars die. Clouds collapse. Black holes grow. But the transformations happen so slowly that a galaxy appears almost frozen when viewed over human timescales. A photograph taken today and another taken thousands of years later would look nearly identical. The galaxy is alive, but it breathes so slowly that we struggle to perceive it. Then there are the giants of patience, white dwarfs. These stellar remnants represent one of the slowest cooling processes in the universe. After stars like our sun die, they leave behind dense cores roughly the size of Earth. Initially, these remnants glow intensely, but without nuclear fusion generating fresh energy, they slowly cool. Very slowly. The cooling process requires trillions of years, not billions. Trillions. The universe itself is only 13.8 billion years old. That means not a single white dwarf has yet completed its cooling journey. Every white dwarf that has ever formed is still in the process of losing heat. The cosmos is simply too young. Imagine beginning a process so slow that the entire current age of the universe represents only the opening chapter. That is the scale we're dealing with. Eventually, these remnants will become black dwarfs, dark stellar embers drifting through an aging universe. But no black dwarfs exist today. The future has not yet lasted long enough. And that future becomes even stranger, because some of the slowest events involve black holes. Black holes often seem violent. They consume matter, they distort space-time, they inspire dramatic stories and spectacular imagery. Yet their ultimate fate is astonishingly gentle. According to theoretical physics, black holes slowly lose energy through a process called Hawking radiation. Tiny quantum effects near the event horizon cause them to emit an incredibly faint form of radiation. As a result, black holes gradually evaporate. But the word gradually barely does justice to the timescales involved. A stellar mass black hole may survive for around 10 to the power of 67 years. That's a 1 followed by 67 zeros. Numbers so large they almost cease to feel meaningful. If human history were represented by a single grain of sand, the lifetime of a black hole would exceed entire deserts of imagination. The last black holes may persist longer than almost anything else in the cosmos, quietly radiating away their energy, year after year, age after age, epoch after epoch, until eventually even they disappear. The universe itself seems to slow down as it ages. Stars become rarer, galaxies drift farther apart. Dark energy stretches space ever wider. Future observers may witness a cosmos increasingly empty and still, not because things stop happening, but because meaningful change becomes spread across unimaginable spans of time. It's almost as though the universe enters a long, contemplative twilight, a phase of existence measured not in centuries or millennia, but in trillions upon trillions of years. And perhaps that is one of the most beautiful lessons hidden within cosmic time. We often feel rushed. Our lives seem brief. Days disappear, years pass. Entire decades slip quietly into memory. Yet the universe operates according to rhythms so slow that our entire civilization resembles a single heartbeat. The stars are patient. Galaxies are patient. Even black holes are patient. Reality itself seems willing to wait longer than we can truly comprehend. There is something strangely comforting about that. The cosmos is not hurrying toward its future. It unfolds carefully, gradually, almost gently. And somewhere beyond the reach of our everyday concerns, ancient stars continue cooling, galaxies continue turning, and black holes continue their impossibly slow evaporation. The universe moves forward, not with urgency, but with extraordinary patience. A patience measured not in lifetimes, but in eternity itself. And as we continue deeper into the hidden corners of creation, we will discover that some of the most remarkable survivors of cosmic history are not the brightest or the largest. They are the objects that simply endure, quietly carrying the story of the universe across unimaginable ages. 5. the stars we almost never see. When most people imagine a star, they picture something magnificent, a blazing giant suspended in darkness, something like our sun, or perhaps an enormous blue-white beacon shining across space, the kinds of stars that dominate astronomy photographs and decorate the covers of science books, bright, powerful, impossible to ignore. But the universe has a habit of hiding its true nature behind appearances, because the stars that capture our attention are not the stars that dominate reality. The overwhelming majority of stars in the cosmos are not brilliant giants. They are not massive blue superstars. They are not dazzling celestial celebrities commanding attention from across the galaxy. Instead, most stars are small, dim, quiet, so faint that many would be invisible even if they were among our nearest neighbors. These are the hidden suns of the universe, the stars we almost never see. And without them, the story of the cosmos would be entirely different. Imagine traveling beyond our solar system and wandering through the Milky Way. You might expect to encounter giant luminous stars everywhere. After all, those are the stars that stand out in telescope images. Those are the stars whose names we learn: Betelgeuse, Rigel, Deneb, and Teres, the cosmic giants. But these famous stars are actually rare exceptions. The universe is not primarily built from giants. It is built from dwarfs. Tiny red stars known as red dwarfs quietly populate the galaxy in astonishing numbers. For every large, brilliant star that dominates the night sky, there are countless small stars hiding in the darkness. Astronomers estimate that roughly 70% of all stars in the Milky Way belong to this category. That means most stars that exist right now are red dwarfs. Most planetary systems likely orbit red dwarfs. And statistically speaking, if you could randomly choose a star anywhere in the galaxy, chances are it would be one of these tiny, hidden suns. Yet most people have never heard of them. Why? Because red dwarfs are incredibly faint. If our sun were replaced with one of these stars, the change would be dramatic. Many red dwarfs produce less than 1% of the sun's brightness. Some emit only a tiny fraction of that. From a great distance, they become nearly invisible. A red dwarf could be lurking relatively close to our solar system and still escape casual observation. It's a little like living in a city filled with billions of candles, while only noticing the occasional spotlight. The candles vastly outnumber the spotlights, but the spotlights are what attract attention. And yet these tiny stars possess remarkable advantages. One of the most extraordinary is longevity. Massive stars live fast and die young. A giant blue star may exhaust its fuel in only a few million years. That sounds like a long time, until you compare it with smaller stars. Red dwarfs burn their fuel with extraordinary efficiency. Their fusion reactions proceed slowly and steadily, like careful savers rather than reckless spenders. As a result, they can survive for trillions of years, not billions, trillions. In fact, the universe is currently too young for even a single red dwarf to have reached the end of its natural life. Every red dwarf ever born is still alive today. Think about that for a moment. The cosmos itself is approximately 13.8 billion years old. Yet these tiny stars are so patient that not one has completed its stellar journey. The first red dwarfs ever formed continue shining. The universe has not existed long enough to watch one die. In a sense, we live during the childhood of the red dwarf era. The future belongs to them. Long after stars like our sun have disappeared, red dwarfs may continue illuminating the darkness. Long after the Milky Way changes beyond recognition, long after many familiar constellations vanish, these hidden suns will still be burning, quietly, steadily, patiently. And because they live so long, astronomers have become increasingly interested in the planets that orbit them. Many exoplanet discoveries in recent years involve red dwarf systems, partly because their small size makes planets easier to detect, but also because there are simply so many of them. Some of these worlds orbit astonishingly close to their stars. A planet may circle a red dwarf in only a few days. What sounds dangerous at first actually makes sense. Because the star is so faint, planets must remain close to receive enough warmth for liquid water. In these systems, a planet's year might last less than a week. Imagine celebrating hundreds of birthdays before reaching adulthood. Yet life around red dwarfs may face unique challenges. Many young red dwarfs are surprisingly active. They unleash powerful stellar flares, bursts of radiation capable of affecting planetary atmospheres. A peaceful-looking star can suddenly erupt with tremendous energy. From a distance, these tiny suns appear calm and harmless. Yet beneath that quiet appearance lies remarkable complexity. Nature rarely creates anything truly simple. Still, the possibility remains fascinating. Because if life can emerge around red dwarfs, then the universe may possess far more habitable environments than we once imagined. After all, if most stars are red dwarfs, then most potentially habitable worlds might orbit red dwarfs as well. The most common homes for life may not resemble Earth at all. Their skies may glow crimson. Their suns may appear larger than ours because of their close proximity. Sunsets, if they occur, may bathe landscapes in deep red hues. Entire civilizations could grow beneath stars very different from the one we know. And perhaps they would look into their own night skies, wondering similar things, wondering whether life exists elsewhere, wondering how large the universe might be, wondering whether other hidden worlds circle other hidden stars. There is something beautiful about that thought, because red dwarfs teach us a lesson that extends beyond astronomy. The universe often places its greatest importance in things that seem ordinary. The brightest stars attract attention, but the small stars dominate reality. The giants command admiration, but the dwarfs inherit the future. Even our own nearest stellar neighbor offers a reminder of this truth. The closest star system to Earth is not dominated by a giant. It includes a tiny red dwarf known as Proxima Centauri, a faint little star almost invisible to the naked eye. Yet it sits closer to us than any other stellar neighbor, quietly shining in the darkness. A hidden sun practically on our cosmic doorstep. And perhaps that is what makes these stars so fascinating. They are not dramatic. They are not spectacular. They do not demand attention. Instead, they simply endure, year after year, billion after billion years, trillion after trillion years. Small lights scattered throughout the galaxy, like embers that refuse to go out, while giant stars explode, while galaxies evolve, while civilizations rise and fall. These tiny suns continue burning, patient witnesses to cosmic history. The stars we almost never see may ultimately become the stars that outlive nearly everything else. And as our journey continues deeper into the universe's hidden places, we will discover that some of the most extraordinary cosmic survivors are not the brightest objects in existence. They are the quiet ones, the overlooked ones, the ancient lights patiently waiting in the dark. 6. Mountains taller than entire planets. If you stood at the base of Mount Everest tonight and looked up toward its icy summit, you would be staring at the tallest mountain on Earth. Its peak rises nearly 9 kilometers above sea level. For generations, humans have viewed Everest as the ultimate symbol of height, a monument to geology, a giant carved by the slow collision of continents. And from a human perspective, it truly is enormous. But the universe has a way of making even our greatest achievements seem surprisingly small. Because beyond Earth exist worlds where mountains may rise to heights that feel almost impossible. Mountains so vast that Everest would look like a modest hill. Mountains taller than entire planets. And perhaps most astonishing of all, these incredible structures may be perfectly natural consequences of physics operating under unfamiliar conditions. Tonight, as we continue our journey through the hidden wonders of the cosmos, let's climb some of the tallest landscapes nature has ever imagined. Not with ropes, not with oxygen tanks, but with curiosity. Let's begin with a mountain that actually exists, a place so enormous that it already stretches the limits of our imagination. On the planet Mars stands a colossal volcano known as Olympus Mons. It is the largest known volcano in the solar system, and calling it a mountain almost feels inadequate. Olympus Mons rises approximately 22 kilometers above the surrounding plains. That's nearly 3 times the height of Mount Everest. Its base stretches hundreds of kilometers across. If placed on Earth, it would cover an area larger than many countries. Standing near its summit, you might not even realize you were on a mountain. Its slopes are so gentle and its scale so enormous that the horizon itself would hide much of the structure. You would be climbing a mountain larger than entire regions of Earth without ever seeing its full shape. So how did Mars build something so gigantic? The answer lies partly in gravity. Mars possesses only about 38% of Earth's gravity. With less gravitational force pulling downward, mountains can grow taller before collapsing under their own weight. On Earth, rock eventually reaches a limit. Gravity wins. The crust bends. The mountain begins sinking into the mantle below. Nature imposes restrictions. But on Mars, those restrictions are weaker. The planet allows mountains to grow larger, much larger. And Mars offers another advantage. Unlike Earth, it lacks active plate tectonics. Here on Earth, tectonic plates drift constantly. Volcanic hotspots move relative to the crust. A volcano forms. Then the plate carries it away. A new volcano forms elsewhere. This process prevents individual volcanic mountains from growing indefinitely. Mars doesn't operate that way. A hotspot can remain beneath the same location for millions of years. Lava continues erupting. Layer upon layer accumulates. The mountain keeps growing, century after century, million year after million year, until eventually you get something like Olympus Mons, a volcano so immense that it feels more like a geological continent than a mountain. Yet even Olympus Mons may not represent the ultimate limit, because elsewhere in the universe, conditions could allow for even stranger landscapes. Imagine a rocky planet somewhat larger than Earth, its crust unusually strong, its internal geology active for billions of years, its gravity carefully balanced. In such environments, mountains might rise far beyond anything we currently observe. Some theoretical studies suggest certain exoplanets could support landforms tens of kilometers high, perhaps even higher under exceptional circumstances. The exact limits depend on gravity, rock strength, temperature, and geological history. But nature has proven repeatedly that when conditions allow something extraordinary, it often happens. And then there are worlds where mountains may not be made of ordinary rock at all. Consider the frozen moons orbiting the giant planets of our solar system. On these distant worlds, ice behaves differently than it does on Earth. At extremely low temperatures, water ice can become as hard as stone. Entire mountain ranges may consist primarily of frozen water. To inhabitants of such hypothetical worlds, ice would not be something fragile or temporary. It would be bedrock, permanent, ancient, massive. Saturn's moon Iapetus provides one of the strangest examples. Running around much of its equator is an enormous ridge system. Some portions rise over 20 kilometers high. No one knows exactly how it formed. Perhaps debris once fell from a vanished ring. Perhaps ancient geological forces pushed the surface upward. Whatever its origin, the result looks almost artificial. A mountain chain encircling an entire moon, like a seam running through a celestial sphere. Nature occasionally creates structures so unusual that they seem to belong in science fiction. But the truly exotic worlds may lie much farther away. Astronomers have discovered thousands of exoplanets. Many differ dramatically from anything found in our solar system. Some are larger than Earth, some smaller, some hotter than molten lava, others colder than Antarctica could ever become. Each new discovery expands our understanding of what planets can be, and with every new category of world comes the possibility of unfamiliar landscapes. Imagine a planet with lower gravity than Mars and an unusually rigid crust. Mountain building processes could continue for immense spans of time. Peaks might rise higher and higher before structural limits intervene. The skyline would appear almost impossible. Jagged towers piercing thin alien atmospheres. Summits reaching heights where the air becomes nearly non-existent. Valleys stretching downward into shadows that sunlight rarely touches. Entire civilizations, if they existed, might spend generations crossing a single mountain range. Then there are worlds that blur the distinction between mountain and planet. Some small moons are dominated by single gigantic structures. The mountain occupies such a large fraction of the body's size that it becomes part of the object's identity. One remarkable example is Rhea Silvia, whose central peak rises an astonishing distance relative to the size of the asteroid itself. On tiny worlds, gravity becomes so weak that enormous structures can survive. A mountain that would instantly collapse on Earth may remain stable for billions of years. And all of this raises a fascinating question. What is the tallest mountain the universe could theoretically create? No one knows. Physics imposes limits. Gravity always has the final word. Eventually, any material reaches a point where its own weight becomes too great. Rock flows, ice deforms, structures collapse. But those limits vary dramatically from world to world. Change the gravity, change the composition, change the temperature, and nature begins rewriting the rules. Somewhere among the countless planets scattered across the galaxy, there may be mountains unlike anything humanity has ever imagined. Peaks that rise so high they create their own weather systems, ranges stretching thousands of kilometers, ancient summits illuminated by faint red stars. Frozen cliffs towering above alien oceans hidden beneath ice. Landscapes shaped not by human imagination, but by the endless creativity of physics itself. And perhaps that's the most wonderful part of exploring the cosmos. Every time we think we've found the largest, the highest, the most extreme example of something, the universe quietly reminds us that our experience is only local. Everest feels immense because it belongs to our world, but the cosmos contains billions of worlds, each with its own possibilities, its own geology, its own stories written in stone, ice, and time. Somewhere out there, hidden beneath distant suns, mountains may stand so tall that they redefine what the word mountain even means. And as our journey continues, we will discover that nature's greatest creations are not always the brightest or the most famous. Sometimes they are silent landscapes, waiting patiently beneath unfamiliar skies, rising higher than we ever thought possible. 7. Oceans hidden beneath frozen skies. At first glance, Earth seems extraordinarily rich in water. When astronauts look back from space, our planet appears blue. Oceans cover more than 70% of its surface. Vast seas stretch from horizon to horizon. Towering waves cross entire continents of water. From our perspective, Earth feels like a world defined by oceans. And yet, as remarkable as our oceans are, they may represent only a tiny fraction of the liquid water that exists in our corner of the cosmos. Because beyond Earth, hidden beneath frozen crusts and endless winter skies, there may be oceans so vast that they contain more water than all of Earth's seas combined. Not exposed beneath sunlight, not glittering under blue skies, but concealed beneath kilometers of ice. Silent, dark, and waiting. Tonight, let's journey to some of the strangest oceans nature has ever created. Not oceans on the surface, but oceans hidden beneath frozen worlds. The idea sounds almost contradictory. When we think of water, we usually imagine warmth, flowing rivers, rainfall, clouds, shimmering coastlines. Ice seems like the opposite of all those things. Frozen, motionless, lifeless. Yet in many places throughout the solar system, ice is not the end of the story. It's merely the roof. Beneath that frozen roof, liquid water may still exist, and in some cases, entire global oceans may be hiding below. One of the most fascinating examples is Jupiter's moon, Europa. At first glance, Europa looks cold beyond imagination. Its surface temperature can plunge below -160 degrees Celsius. The landscape appears locked in eternal winter. A smooth shell of ice stretches across the moon like frozen marble. No rivers, no lakes, no visible seas. Nothing about the surface suggests an oceanic world. And yet, astronomers believe Europa may contain a global liquid ocean beneath that icy crust. An ocean that could be over 100 kilometers deep in some regions. To appreciate how extraordinary that is, consider Earth's oceans. The average depth of Earth's oceans is only about 4 kilometers. Europa's hidden sea may be many times deeper. In total, it may contain more liquid water than all of Earth's oceans combined. Think about that for a moment. An entire ocean world hidden beneath ice. A place where sunlight has never penetrated. A place where waves may have rolled for billions of years in complete darkness. If you somehow stood on Europa's surface, you would see only frozen wilderness stretching endlessly toward the horizon. Yet beneath your feet, an entire ocean could be moving silently through the darkness. a hidden sea beneath a frozen sky. How is this possible? The answer lies in gravity. Europa experiences powerful tidal forces from Jupiter. The giant planet constantly squeezes and stretches the moon. This gentle but relentless flexing generates heat deep within Europa's interior. Not enough heat to melt the surface, but enough to keep water liquid far below. It's a bit like repeatedly bending a paperclip. Eventually, it becomes warm. Europa experiences that process on a planetary scale. The result is an ocean hidden beneath ice. And Europa is not alone. Another remarkable world waits even farther away. Saturn's moon Enceladus is much smaller than Europa, only about 500 kilometers across. At first glance, it resembles a bright, frozen snowball drifting through space. Yet beneath its icy shell lies another hidden ocean. Scientists discovered something astonishing there. Enormous geysers erupt from cracks near the moon's south pole. Jets of water vapor shoot hundreds of kilometers into space, like cosmic fountains. These plumes contain water, salts, organic molecules, and other intriguing ingredients. They offer direct evidence that liquid water exists below the surface. Imagine standing near one of those icy fissures. Above you stretches a black sky filled with stars. Around you lies a frozen desert. Yet beneath the ice, warm water circulates through an unseen ocean, a hidden world concealed beneath layers of frozen silence. And then things become even more extraordinary, because some moons may contain oceans stacked between layers of ice. Imagine a frozen shell, then an ocean, then another layer of ice, then perhaps another ocean beneath that. Entire aquatic worlds arranged like cosmic layer cakes. Nature seems surprisingly creative when given enough time. One particularly fascinating candidate is Saturn's moon, Titan. Titan is already famous for possessing rivers, lakes, and seas on its surface, but these aren't made of water. They consist primarily of liquid methane and ethane. Imagine standing beside a shoreline where the waves are made of natural gas, a place where rain falls from hydrocarbon clouds, a world that looks strangely Earth-like while being completely alien. Yet beneath Titan's frozen crust may also exist a hidden ocean of liquid water, an ocean buried beneath layers of ice and hydrocarbons. Two entirely different liquid worlds occupying the same moon, one on the surface, one hidden below. The deeper scientists look, the more common these hidden oceans appear to become. Some researchers now suspect that ocean worlds may be among the most common habitable environments in the galaxy. Not Earth-like planets, not tropical worlds beneath bright suns, but frozen worlds with hidden seas. This possibility changes the way we think about life itself. For much of human history, we assumed sunlight was essential. After all, nearly every ecosystem on Earth ultimately depends on solar energy. Plants capture sunlight. Animals depend on plants. Entire food chains begin with the sun. But Earth's own oceans contain surprises. Deep near hydrothermal vents, life thrives in complete darkness. These ecosystems receive no sunlight whatsoever. Instead, they draw energy from chemical reactions occurring within Earth's crust. Bacteria feed on chemicals emerging from the vents. Larger organisms feed on the bacteria. Entire communities flourish far below the reach of sunlight. If life can survive there, perhaps it can survive elsewhere. Perhaps beneath Europa's ice. Perhaps beneath Enceladus. Perhaps beneath countless frozen worlds scattered throughout the galaxy. Imagine an ocean that has existed for billions of years, protected from asteroid impacts, shielded from harsh radiation, stable and isolated beneath kilometers of ice. If life ever emerged in such an environment, it might have had immense stretches of time to evolve. Not beneath blue skies, not beneath stars, but beneath frozen ceilings stretching across entire worlds. There is something strangely comforting about these hidden oceans. When we think of the universe, we often picture empty space, cold darkness, silent voids. Yet hidden beneath many of those frozen surfaces may be environments filled with movement, currents, tides, chemistry, perhaps even ecosystems. The universe may be far wetter than it appears. Many of its oceans simply happen to be concealed, and perhaps that's a recurring lesson of cosmology. the most important things are not always visible. Stars dominate our attention, but hidden red dwarfs dominate the galaxy. Planetary surfaces capture our imagination, but hidden oceans may contain most of the water. What appears empty often conceals extraordinary complexity. As we continue our journey deeper into the hidden corners of the cosmos, remember this image. Somewhere beneath a frozen crust, orbiting a distant giant planet, dark waters may still be flowing. Ancient currents may still be moving. Perhaps they have been moving continuously since before Earth developed complex life. Entire oceans hidden beneath frozen skies, silent, invisible, patiently waiting beneath the ice. And if you're enjoying these peaceful cosmic stories, save this video so you can return to it whenever you need a quiet journey among the stars. 8. The galaxies that disappeared. Look up at the night sky for a moment. Every star you can see belongs to a galaxy. Our sun is part of the vast spiral structure we call the Milky Way. Around us lie billions of other galaxies, scattered across the observable universe like islands in an unimaginably large cosmic ocean. Some are majestic spirals, some are giant ellipticals. Others are small dwarf galaxies barely holding themselves together. When we observe them through powerful telescopes, they can feel permanent, timeless, almost eternal. Yet galaxies are not eternal. They are born, they evolve, they change, and sometimes they disappear. Tonight, let's travel into one of the quieter mysteries of cosmic history. The story of galaxies that formed, flourished, and vanished long before Earth ever existed. Galaxies whose light faded into darkness billions of years ago. Galaxies that are gone, yet still leave faint fingerprints across the universe. At first, the idea may seem strange. After all, galaxies are enormous. The Milky Way contains hundreds of billions of stars. How could something so vast simply disappear? The answer lies in understanding that the universe itself is constantly changing. Nothing remains exactly the same forever. Not stars, not planets, not even galaxies. To understand this, let's travel back in time. Far beyond human history, far beyond dinosaurs, far beyond the formation of Earth itself. Imagine the universe less than 1 billion years after the Big Bang. The cosmos looked very different then. No familiar Milky Way, no solar system, no Earth. The first generations of galaxies were just beginning to emerge from the darkness. Many were small, chaotic, violent places filled with furious bursts of star formation. Gas clouds collapsed rapidly. Massive stars ignited. Supernovae exploded constantly. Entire galaxies blazed with youthful energy. For a brief period, some of these ancient systems may have shone brighter than much larger galaxies do today. They were cosmic fireworks displays, brilliant, restless, short-lived. Many of those early galaxies no longer exist in their original form. Some merged together, others were torn apart. Still others exhausted the gas needed to create new stars and slowly faded into obscurity. In a sense, much of the modern universe is built from their remains. Think of galaxies not as permanent objects, but as living ecosystems. Stars are born, stars die. Gas flows inward and outward. Gravity pulls neighboring systems together. Over billions of years, galaxies grow through countless collisions and mergers. The Milky Way itself is a product of this process. Astronomers have discovered evidence that our galaxy absorbed many smaller galaxies during its long history. Some of these ancient galaxies no longer exist as independent objects. They were consumed, their stars scattered throughout the Milky Way, their identities erased by time. Yet traces remain, like archaeological ruins buried beneath a modern city. One remarkable example is the ancient progenitor galaxy, sometimes called Gaia Enceladus. Billions of years ago, it collided with the young Milky Way. The event dramatically reshaped our galaxy. Today, the original galaxy is gone, its structure destroyed, its stars dispersed. But astronomers can still identify many of those stars moving through the Milky Way, ghostly remnants of a galaxy that disappeared long before Earth formed. It's a fascinating thought. Some stars visible in our sky tonight may have originated in galaxies that no longer exist. They are cosmic immigrants, travelers from forgotten worlds, survivors of ancient galactic catastrophes. And sometimes entire galaxies seem to fade away not through destruction, but through exhaustion. Galaxies live by creating stars. New stars provide light, energy, structure, activity. But star formation requires fuel, primarily hydrogen gas. Eventually, some galaxies run low on that fuel. When star formation slows or stops, the galaxy begins changing. The bright blue stars that once dominated its appearance die first. These massive stars burn through their fuel quickly. After they disappear, only older red stars remain. Gradually, the galaxy grows dimmer, redder, quieter. Astronomers sometimes refer to these systems as red and dead galaxies. Not because every star has vanished, far from it, but because the galaxy's era of vigorous growth has ended. Its most active chapter is over. Imagine visiting such a galaxy. No brilliant stellar nurseries, no vast glowing clouds of newborn stars, just ancient suns orbiting through darkness, a city whose greatest days lie billions of years in the past. Yet perhaps the most dramatic disappearances occur because of the expansion of the universe itself. Earlier tonight, we explored how space continually expands. Galaxies drift farther apart over time, and that expansion is accelerating, driven by the mysterious influence of dark energy. This creates an astonishing consequence. Many distant galaxies are gradually slipping beyond our observable reach, not because they cease to exist, but because space between us expands too rapidly. Their light can no longer overcome the growing distance. Imagine standing on a shoreline while a ship sails away. Eventually, it disappears beyond the horizon. The ship still exists. You simply cannot see it anymore. The universe behaves similarly on cosmic scales. Billions or even trillions of years in the future, observers living within the Milky Way's descendants may see only a handful of nearby galaxies. The rest will have vanished beyond the cosmic horizon. Entire galactic civilizations could disappear from view forever. Future astronomers may never know they existed. This realization carries a strangely melancholy beauty. The universe is not merely changing, it is slowly becoming lonelier. One by one, distant galaxies fade from sight, not through destruction, but through separation. The night sky itself evolves. And perhaps the most haunting galaxies of all are those we can barely detect today. The faintest relics from the earliest cosmic ages. Astronomers use powerful instruments to peer billions of years into the past. Because light requires time to travel, looking far away means looking backward in time. Some galaxies observed today appear as they existed more than 13 billion years ago. We see them not as they are now, but as they were when the universe was young. Many of these systems may have changed beyond recognition. Some may have merged into larger galaxies. Others may have completely disappeared. Their ancient light continues traveling through space long after their original forms have vanished. It's like receiving a letter from someone who lived thousands of years ago. The message survives. The sender does not. The deeper we look into the universe, the more we become historians. Every telescope becomes a time machine. Every distant galaxy becomes a fossil. Every faint photon carries memories from epochs long gone. And perhaps that is what makes galaxies so fascinating. They are not static collections of stars. They are stories. Stories written across billions of years. Stories of creation, growth, collision, transformation, and disappearance. Some galaxies become giants. Some remain dwarfs. Some merge together. Some fade quietly into darkness. And many leave behind only subtle clues for future civilizations to discover. As we drift onward through tonight's peaceful journey, imagine the countless forgotten galaxies that once illuminated the young cosmos. Entire star cities that flourished before Earth existed. Ancient spiral arms glowing beneath primordial skies. Generations of stars living and dying before our sun was even born. Most are gone now, absorbed, transformed, scattered, or hidden beyond horizons we cannot cross. Yet their legacy remains everywhere. In the stars around us, in the structure of the galaxies we see today, and perhaps even within the atoms that eventually became us. The universe remembers more than it reveals, and somewhere among the oldest light still traveling through space are the final whispers of galaxies that disappeared long ago, leaving only faint clues behind. 9. The most ancient light still traveling. Right now, as you sit quietly beneath the night sky, something extraordinary may be happening inside your room. Invisible streams of ancient light are passing through the walls, through the air, through your body. Photons that have traveled unimaginable distances continue their silent journey across the cosmos. Most arrive unnoticed. Most carry stories too old for human intuition to fully grasp. And some of them began their voyage before our galaxy looked anything like it does today. Before the sun existed. Before Earth formed. Before the familiar spiral arms of the Milky Way settled into their present shape. Tonight, we follow those travelers. The oldest light still moving through the universe. The ancient messengers that have crossed billions of years simply to arrive here, now, in this quiet moment. When most people think of ancient objects, they imagine fossils, ancient trees, old mountains, perhaps relics buried beneath desert sands. But light can be ancient too. In fact, some of the oldest things we can ever observe are not objects at all. They are photons, tiny packets of light, massless travelers that move through the vacuum of space at nature's ultimate speed limit. Unlike stars, photons do not age in the way we do. They do not grow old. They do not wear down. They simply travel, year after year, million after million years, billion after billion years, crossing the universe without rest. The most famous example is the ancient glow known as the cosmic microwave background. Earlier in our journey, we touched briefly upon this remarkable light, but now let's look at it from a different perspective. Imagine a photon born approximately 380,000 years after the Big Bang. The universe was still incredibly young. No galaxies existed yet. No stars illuminated the darkness. No planets orbited distant suns. The cosmos was only beginning to become transparent. Before that moment, light could not travel freely. The early universe was filled with a dense fog of charged particles. Photons bounced endlessly in every direction. Then the fog lifted. Atoms formed. Space became transparent, and countless photons were suddenly released. Those photons have been traveling ever since. Some have crossed more than 13 billion years of cosmic history. Some are passing through your room right now. That thought is difficult to fully absorb. A particle of light that began moving when the universe itself was in cosmic infancy is still traveling today. Civilizations have risen and fallen. Stars have been born and died. Galaxies have collided. Entire cosmic structures have transformed. Yet those photons continue onward, patient, silent, persistent. The universe's oldest surviving travelers. If you could somehow see microwave radiation with your eyes, the entire sky would glow softly. Not with starlight, not with the light of nearby galaxies, but with the lingering afterglow of creation itself. Every direction would reveal the same ancient illumination. A cosmic memory still stretching across space. And the cosmic microwave background is only part of the story. Other ancient photons travel through the universe as well. Some originated from the earliest generations of stars. These stars were unlike most stars we see today. Astronomers call them population 3 stars. They formed when the universe contained almost nothing except hydrogen and helium. No carbon, no oxygen, no iron. None of the heavier elements that would later build planets and people. These first stars were likely enormous, hundreds of times more massive than the sun, brilliant beyond imagination, and tragically short-lived. Many burned for only a few million years before exploding. Compared to our sun's expected lifespan of roughly 10 billion years, they lived only brief cosmic moments. Yet during those moments, they transformed the universe forever. Inside their cores, the first heavy elements were forged: carbon, oxygen, silicon, iron. The ingredients that would eventually build worlds. The ingredients that would eventually build us. The stars themselves vanished long ago. None are expected to survive today. but some of the photons they emitted continue traveling. Ancient starlight crossing the universe long after its source disappeared. Imagine receiving a message from a civilization that vanished billions of years ago. That is essentially what astronomy allows us to do. Every distant photon is a letter from the past. Every telescope becomes a machine for reading ancient history. The farther we look, the farther back in time we see. This creates one of the most beautiful paradoxes in astronomy. When we observe the most distant objects, we are actually observing the youngest universe. A galaxy located 13 billion light-years away appears not as it is today, but as it was 13 billion years ago. The photons arriving at our telescopes began their journey before Earth existed, before the solar system formed, before countless generations of stars lived and died. The universe preserves its own history in light. And every night, that history continues arriving, one photon at a time. There is something wonderfully peaceful about this. The universe often feels enormous and impersonal. Distances are vast, timescales are overwhelming. Yet ancient photons connect us directly to events that occurred billions of years ago. They bridge epochs. They erase separation. A particle born near the dawn of cosmic history can end its journey by striking a detector built by curious primates on a small, rocky planet. That is an extraordinary connection. In a sense, astronomy is not merely observing space. It is listening to memories. The night sky becomes an archive. Every star a chapter, every galaxy a volume, every photon a sentence written long ago. And perhaps the most astonishing thing is how fragile these messengers are. A photon carries only a tiny amount of energy, yet it survives journeys spanning billions of light years. It crosses expanding space. It avoids dust clouds. It threads its way through galaxies. It continues onward despite obstacles beyond imagination. Eventually, one may encounter a telescope, a sensor, or perhaps even your eye. And after billions of years of travel, its journey ends. Not with a dramatic explosion, not with a cosmic event, but with a tiny interaction, a final delivery of information, a message received. As the universe continues expanding, these ancient photons will become increasingly stretched. Their wavelengths will grow longer, their energy will diminish. The oldest light will become fainter and fainter. In the unimaginably distant future, much of this ancient radiation may become nearly impossible to detect. Future civilizations, if any exist, may find it difficult to reconstruct the universe's earliest history. The evidence available to us today is precious. We happen to live during a remarkable era, an era when the oldest light remains visible, an era when cosmic history is still written across the sky. And perhaps that realization makes tonight feel a little different. As you sit here listening, surrounded by quiet darkness, ancient photons continue passing through the room. Some began traveling before the Milky Way fully formed. Some started their journey before the sun existed. Some have crossed nearly the entire observable universe. They arrive carrying stories older than mountains, older than oceans, older than life itself. Silent travelers from the dawn of time, still moving, still crossing space, still whispering their ancient story to anyone patient enough to listen. And in that sense, every night sky is more than a collection of stars. It is a meeting place between the present moment and the deepest past imaginable. A place where the oldest light in existence continues its endless journey through the darkness. 10. Cosmic objects that shouldn't exist. The universe is often described as elegant. Its laws appear orderly, predictable, beautifully mathematical. Gravity shapes galaxies. Nuclear fusion powers stars. Relativity governs space-time. Quantum mechanics orchestrates the microscopic world. For the most part, the cosmos behaves according to rules we have spent centuries uncovering. And yet, every so often, the universe surprises us. Astronomers point their telescopes toward the heavens, expecting to find one thing, and discover something entirely different. Something strange, something unexpected, something that at least at first glance shouldn't exist at all. Tonight, let's wander through some of the most puzzling objects ever discovered. cosmic oddities that challenged our understanding of reality itself. Objects that forced scientists to rethink theories, rewrite textbooks, and admit one of the most important phrases in science: we don't fully understand this yet. One of the most famous examples emerged from an unexpected discovery in the 1960s. Astronomers began detecting mysterious radio signals arriving from deep space. The signals pulsed with astonishing precision, over and over, like a cosmic lighthouse, or perhaps, as some jokingly suggested, a message from an alien civilization. The first detected source was temporarily nicknamed LGM-1, short for Little Green Men. Of course, the explanation turned out to be even more fascinating. The signals came from an entirely new type of object, a pulsar, a rapidly spinning neutron star left behind after a massive star exploded as a supernova. Imagine squeezing more mass than our sun into a sphere only about 20 kilometers across. Matter becomes so compressed that a single teaspoon would weigh billions of tons. These stars spin incredibly fast. Some rotate hundreds of times per second. They sweep beams of radiation through space like giant cosmic lighthouses. Every pulse we detect is a reminder that nature can create objects far stranger than anything human imagination initially proposed. And yet pulsars are almost ordinary compared to some later discoveries. Consider magnetars. If neutron stars are extreme, magnetars are extreme versions of the extreme. These objects possess magnetic fields so powerful they defy common understanding. A refrigerator magnet might have a magnetic field of about 100 Gauss. Earth's magnetic field is roughly half a Gauss. A magnetar can possess a field strength exceeding 1 quadrillion Gauss. The numbers become almost meaningless. If a magnetar passed halfway between Earth and the Moon, its magnetic field could disrupt electronics across our planet. Fortunately, the nearest known examples remain safely distant. But their existence raises an important question. How does nature create something so absurdly powerful? Even now, scientists continue studying these extraordinary stellar remnants. Then there are black holes, not merely because they are mysterious, but because some of them appear far too large, far too early. When astronomers began observing the young universe, they discovered enormous supermassive black holes already existed less than 1 billion years after the Big Bang. This posed a serious problem. Growing black holes takes time. Matter must fall inward, mass must accumulate. Yet some black holes seem to have reached billions of solar masses almost immediately by cosmic standards. It was as if a sapling had somehow become an ancient redwood overnight. Theories continue evolving to explain how these giants formed so quickly. Perhaps they were born unusually massive. Perhaps early cosmic conditions accelerated their growth. Or perhaps some ingredient remains missing from our current models. The universe has not revealed the full answer yet. And that uncertainty is part of the adventure. Another remarkable mystery emerged with the discovery of rogue planets. For generations, planets were thought to belong to stars. That seemed obvious. After all, every planet in our solar system circles the sun. Planets and stars appeared inseparable. Then astronomers found evidence of worlds drifting freely through interstellar space. No parent star, no sunrise, no sunset. Just endless darkness. Some may have been ejected from planetary systems during violent gravitational encounters. Others may have formed independently. Entire worlds wandering alone between the stars. The idea feels almost poetic. A planet with no sun. An orphan world crossing the galaxy in silence. A place where night lasts forever. And then we arrive at one of the strangest discoveries of all. Fast radio bursts, known simply as FRBs. These events appear as sudden bursts of radio energy lasting mere milliseconds. Yet during that brief instant, they can release as much energy as the sun emits over several days. The first detections left astronomers baffled. The bursts appeared unexpectedly, then vanished. For years, nobody knew what caused them. Speculation flourished. Neutron stars, black holes, exotic astrophysical processes. Perhaps something entirely unknown. Today, many FRBs appear linked to magnetars, yet the complete picture remains uncertain. Nature still guards some of its secrets. And perhaps that is fitting. Because every time science solves one mystery, another often appears nearby. Even entire stars have challenged expectations. Take blue stragglers. These peculiar stars appear younger than their neighbors. In ancient star clusters where most stars should have aged together, blue stragglers stand out as youthful exceptions. Bright, hot, unexpected. It's as though a retirement community suddenly contained a handful of energetic 20-year-olds. Astronomers eventually realized many blue stragglers form through stellar mergers or mass transfer between companion stars. Yet their existence reminds us that stellar evolution is rarely simple. Stars have complicated lives. Sometimes they refuse to follow expectations. Even galaxies can behave strangely. Some galaxies appear almost entirely composed of dark matter. Others seem to contain surprisingly little. There are galaxies so diffuse that they resemble faint ghosts drifting through space. Huge structures with relatively few stars, barely visible against the darkness. They challenge assumptions about how galaxies form and survive. The deeper we look into the universe, the stranger it becomes. And perhaps nowhere is this more evident than with hypothetical objects that may exist but have never been directly observed. Objects like quark stars, theoretical remnants even denser than neutron stars, or primordial black holes that might have formed shortly after the Big Bang itself, or exotic dark matter structures lurking unseen throughout the cosmos. Scientists continue searching. Some of these objects may eventually be discovered, others may turn out not to exist at all. But the search itself expands our understanding. Theories are tested, predictions are refined, questions become more precise, and slowly the boundaries of knowledge move outward. There is something deeply comforting about this process. We often imagine science as a collection of answers, but in reality, science thrives on mysteries. The unknown drives discovery. The unexplained inspires curiosity. Every strange object discovered in the sky is an invitation, an opportunity to learn something new about reality. A reminder that nature remains far more creative than we are. And perhaps that is one of the universe's most beautiful qualities. No matter how much we learn, surprise remains possible. Somewhere tonight, hidden among billions of stars and galaxies, there may be objects we have never imagined. Phenomena unlike anything currently described in textbooks. Structures stranger than black holes. Worlds more exotic than rogue planets. Entire categories of cosmic objects waiting quietly to be discovered. The universe is under no obligation to match our expectations, and thankfully, it rarely does. As we continue our gentle journey through the hidden corners of the cosmos, let that thought settle softly into your mind. Far beyond Earth's skies, beyond familiar stars and distant galaxies, reality continues creating wonders we have not yet named. Objects that challenge our theories, objects that stretch our imagination, objects that seem impossible until the moment we discover they are real. And somewhere in that vast darkness, the next cosmic surprise may already be waiting. 11. The last fires of dead stars. There is a common belief that stars die dramatically, a brilliant explosion, a final flash of light, a brief cosmic farewell before fading forever into darkness. And in many cases, that picture is true. Massive stars end their lives in spectacular supernova explosions. For a short time, they can outshine entire galaxies. Their deaths scatter heavy elements across space. The carbon in your cells, the oxygen you breathe, the iron in your blood. Much of it was forged inside stars that died long before Earth existed. But the story doesn't end there, because some stars refuse to disappear completely. Long after their nuclear fires have gone out, they continue glowing, continue cooling, continue radiating energy into the darkness. Not for millions of years, not even billions, but for periods so vast that human history becomes invisible against them. Tonight we journey into the last fires of dead stars, the lingering embers of a universe that takes an extraordinarily long time to cool down. To understand these cosmic remnants, we must first remember what keeps a normal star alive. A star is essentially a battle. Gravity pulls inward, trying to crush the star. Meanwhile, nuclear fusion pushes outward. Deep within the core, hydrogen atoms combine into helium. Mass becomes energy. Light is born. Heat floods outward. For billions of years, these two forces balance one another. Gravity pulls, fusion resists, the star survives. But eventually, the fuel runs low, and every star, no matter how large or small, must face that reality. For stars similar to our Sun, the ending is surprisingly gentle. There is no violent explosion, no dramatic collapse into a black hole. Instead, the star slowly swells into a red giant. Its outer layers expand outward. Nearby planets may be engulfed. The inner planetary system transforms forever. Then, after shedding much of its atmosphere into space, the remaining core is exposed. What remains is called a white dwarf. At first glance, white dwarfs seem almost impossible. Imagine squeezing roughly the mass of the Sun into an object about the size of Earth. Matter becomes incredibly dense. Gravity becomes immense. A teaspoon of white dwarf material would weigh several tons. Yet despite their incredible density, white dwarfs are no longer truly alive. Fusion has ended. Their nuclear engines have shut down. They are stellar corpses. And yet they continue shining. Why? Because they are still hot, extremely hot. When a white dwarf first forms, its temperature can exceed 100,000 degrees Celsius. The star no longer generates new energy. Instead, it slowly releases heat stored from its earlier life. Like an enormous cosmic coal removed from a fire. The glow remains long after the flames disappear. And here's where the timescales become extraordinary. White dwarfs cool incredibly slowly. Not millions of years, not billions, trillions. The universe itself is only about 13.8 billion years old. Not a single white dwarf has existed long enough to fully cool. Every white dwarf ever created still radiates heat. Every one remains warm. The oldest stellar embers in existence are still glowing tonight, quietly fading, patiently waiting. Their journey toward darkness has barely begun. Astronomers predict that after trillions upon trillions of years, white dwarfs will eventually become something even stranger. Black dwarfs, cold stellar remnants no longer visible to the naked eye, frozen cinders drifting through the darkness. Interestingly, black dwarfs do not yet exist. The universe is simply too young. Think about that for a moment. There are entire categories of objects that physics predicts, but time has not yet allowed to form. The cosmos is still early in its story. Even now, even after billions of years, the age we inhabit is merely the opening chapters of a much longer tale. And white dwarfs are not the only stellar ghosts lingering after death. Consider neutron stars. These extraordinary remnants form when massive stars explode as supernovae. The core collapses so violently that protons and electrons merge together. Matter becomes packed almost entirely into neutrons. The result is astonishing. An object roughly 20 kilometers across, containing more mass than the Sun. The density is difficult to comprehend. A sugar cube-sized piece would outweigh a mountain. Neutron stars initially shine through their residual heat. Some emit powerful beams of radiation, others become pulsars, rotating hundreds of times each second, sweeping invisible lighthouse beams across the galaxy. Even after the explosive death of their parent stars, these remnants continue influencing the universe for billions of years, and some may persist for periods far beyond that. The universe is remarkably reluctant to let things end. Energy lingers, heat remains, motion continues. Cosmic endings often resemble transformations more than disappearances. This becomes especially fascinating when we look toward the unimaginably distant future. Imagine a universe trillions of years from now. Most stars have exhausted their fuel. Galaxies grow dimmer. Bright stellar nurseries become increasingly rare. The great age of star formation begins to fade. Yet scattered throughout the darkness, countless white dwarfs continue cooling. Neutron stars continue drifting. Black holes continue feeding on occasional matter. Tiny pockets of energy remain, like campfires long after a festival ends. The universe slowly transitions from brilliance to twilight. Not suddenly, but gradually, almost imperceptibly. If a human life were compressed into a single second, these changes would occur over timescales longer than entire civilizations multiplied billions of times. Cosmic patience exceeds anything familiar to us. Even black holes contribute to this story. For many years, physicists assumed black holes simply lasted forever. Then came one of the most remarkable discoveries in theoretical physics, the insight of physicist Stephen Hawking. According to quantum mechanics, black holes slowly emit radiation. Today we call it Hawking radiation. The process is unimaginably slow. Large black holes lose mass at an almost negligible rate, but given enough time, even they evaporate. A stellar mass black hole may survive for around 10 to the power of 67 years. Supermassive black holes endure even longer, yet eventually even these cosmic giants fade away. Their final flashes occur in a universe older than anything we can meaningfully picture. It is one of the most astonishing ideas in science. The largest, darkest objects in existence are not eternal. They too possess endings. And yet those endings lie so far ahead that the entire history of life on Earth feels like a brief spark by comparison. There is something deeply soothing about these timescales. Our lives often feel rushed. Days pass quickly. Years seem shorter with age. History itself can feel fleeting. But the universe operates differently. Stars cool for trillions of years. Black holes evaporate over incomprehensible ages. Cosmic remnants linger long after their creators vanish. Nothing is hurried. Everything unfolds gradually, patiently, quietly. Perhaps that is why these dying stars feel strangely comforting. They remind us that endings are rarely absolute. The death of a star is not a disappearance. It is a transition, a transformation into something new, a lingering warmth carried forward into deep time. And somewhere out there tonight, countless white dwarfs continue glowing softly in the darkness. Ancient stellar hearts slowly releasing the last heat of long-forgotten suns. Some once illuminated planetary systems. Some may have hosted worlds. Some perhaps witnessed life emerge on distant planets before fading into old age. Now they drift through the galaxy as cosmic embers, not alive, not entirely gone, simply enduring. Their final fires still burning, their last warmth still radiating, their story still unfolding across trillions of years, long after the stars themselves have died. 12. The quiet architecture of gravity. If you could somehow step outside the Milky Way and look at the universe from far above, you might expect to see chaos. Billions of galaxies scattered randomly through space, stars drifting aimlessly through darkness, clusters appearing wherever chance happened to place them. A cosmic accident, messy, disorganized, without structure. But that is not what the universe looks like. The deeper astronomers have looked into space, the more surprising the picture has become. The cosmos is organized, not perfectly, not neatly, but on the largest scales imaginable, galaxies gather into enormous patterns. Filaments, clusters, walls. Vast interconnected structures stretching hundreds of millions of light years across space. And perhaps most remarkably of all, much of this architecture is built by something we cannot directly see. Gravity. Silent, invisible, patient. The great cosmic architect. Tonight, let's explore the hidden structures gravity has spent billions of years building, the quiet architecture of the universe itself. At first glance, gravity seems familiar. It's what keeps your feet on the ground. It guides the moon around Earth. It keeps planets orbiting stars. Simple enough. But gravity behaves very differently when given enough time. And the universe has had plenty of time. Almost 14 billion years. Imagine a perfectly calm lake. Drop a pebble into it. The ripples spread outward. Tiny disturbances gradually influence larger regions. Now imagine something similar happening shortly after the Big Bang. The early universe was astonishingly smooth. Not perfectly smooth, but remarkably close. Tiny differences in density existed. Some regions contained slightly more matter, others slightly less. The differences were almost unimaginably small, yet gravity notices even the smallest imbalance. A region with slightly more matter has slightly stronger gravity. That stronger gravity attracts more matter. which creates even stronger gravity, which attracts even more matter. Slowly, relentlessly. Over billions of years, those tiny ripples grew. Small fluctuations became enormous structures. The first stars formed, then galaxies, then clusters of galaxies. Gravity patiently sculpted complexity from simplicity, and the result is extraordinary. Today, galaxies are not distributed evenly throughout space. Instead, they form a vast network known as the cosmic web. Imagine looking at a spider web stretched across the entire observable universe, except the strands are hundreds of millions of light years long. Galaxies gather along these immense filaments. At the intersections, enormous galaxy clusters form. Between them lie gigantic voids, regions of space so empty they contain very few galaxies at all. Some of these voids are hundreds of millions of light years across. If you lived inside one, the night sky would appear strangely lonely. Entire regions of the cosmos contain far fewer galaxies than average. The universe is not a uniform ocean. It is a landscape, a terrain shaped by gravity. Mountains of galaxies, valleys of emptiness, rivers of matter flowing slowly through cosmic time. What's remarkable is that much of this structure is controlled by something even stranger: dark matter. Unlike ordinary matter, dark matter does not emit light. It doesn't glow, it doesn't reflect, it doesn't shine. Astronomers cannot see it directly, and yet they know it exists, because gravity reveals its presence. Galaxies rotate too quickly, clusters contain too much mass. Light bends more strongly than visible matter alone can explain. Everywhere astronomers look, gravity seems to whisper the same message. There is more here than meets the eye. Much more. In fact, ordinary matter, the stars, planets, gas clouds, and galaxies we can see, makes up only a small fraction of the universe's total matter. Dark matter appears to dominate the cosmic landscape. Invisible scaffolding surrounds galaxies. Massive halos of unseen matter stretch far beyond their visible edges. These halos act like gravitational foundations. Without them, many galaxies might never have formed. The Milky Way itself sits inside one of these enormous dark matter structures. Right now, as you listen, our galaxy is moving through an invisible sea of dark matter. You cannot feel it. You cannot see it, yet it surrounds us, a hidden component of reality flowing silently through the cosmos. The more astronomers map the universe, the more clearly this invisible architecture emerges. Massive surveys have revealed vast cosmic walls stretching across unimaginable distances. One of the largest known structures is the Hercules Corona Borealis Great Wall, a structure so immense it challenges intuition. Spanning billions of light years, its scale is almost difficult to comprehend. If Earth were a grain of sand, these structures would dwarf entire continents of imagination. And yet, gravity built them gradually, patiently, one tiny pull at a time. Gravity is often described as the weakest of nature's fundamental forces. A small refrigerator magnet easily overcomes Earth's gravitational pull on a paperclip. Yet gravity possesses one enormous advantage. It never switches off. It always attracts. It never cancels itself. Given enough time, even a weak force can become powerful. And the universe has given gravity billions upon billions of years to work. That patience has transformed the cosmos. Every galaxy cluster, every filament, every enormous structure exists because gravity had time to build it. Like a master architect constructing a cathedral over millions of generations. Slow, steady, unstoppable. Perhaps nowhere is gravity's artistry more beautiful than in gravitational lensing. According to Einstein's theory of general relativity, gravity does not simply pull objects, it bends space-time itself. Massive objects warp the geometry of reality. Light follows those curves. As a result, distant galaxies sometimes appear distorted, stretched into arcs, multiplied into rings, magnified like images seen through a giant cosmic lens. These distortions allow astronomers to map invisible dark matter. They reveal hidden structures otherwise impossible to detect. Gravity becomes both sculptor and storyteller, shaping the universe while simultaneously revealing its secrets. And yet, gravity's work continues. The architecture is not finished. Galaxies still move, clusters still merge, structures still evolve. The universe remains under construction. Far in the future, gravity will continue rearranging matter long after many stars have died. Galaxies will collide, clusters will merge, entire regions of space will slowly transform. The cosmic web itself will continue evolving across timescales that dwarf human history. There is something deeply calming about this. We often imagine the universe as a place of explosive events, supernovas, black holes, gamma-ray bursts, violent phenomena grabbing headlines across the cosmos. But most of the universe is shaped by something quieter, something slower. Gravity rarely rushes. It works patiently, a subtle force accumulating influence over billions of years, building structures too large for any individual civilization to witness forming. Like roots spreading beneath a forest, or rivers slowly carving canyons through stone. Its greatest achievements emerge through persistence, not speed. And perhaps that is why the universe feels so harmonious on large scales. Beneath all the apparent chaos lies an invisible order, a hidden framework connecting galaxies across unimaginable distances, an architecture built without blueprints, without intention, without design, yet somehow producing structures of breathtaking beauty. As you drift deeper into tonight's journey, imagine those invisible rivers of gravity flowing through space, guiding galaxies, shaping clusters, pulling matter into magnificent patterns stretching across billions of light years. A silent network connecting the cosmos, an unseen architecture supporting everything we know. And while we may never directly see these vast gravitational currents, we can see their handiwork everywhere. In the arrangement of galaxies, in the bending of light, in the structure of the cosmic web itself. Gravity leaves fingerprints across the universe. Quiet, patient, invisible, yet powerful enough to shape the destiny of entire galaxies. And perhaps, in its own gentle way, gravity reminds us that the most important forces are not always the loudest. Sometimes they're the quiet ones, the ones working steadily in the background, building wonders over spans of time so vast they feel almost eternal. If these mysteries of the universe fascinate you, share this video with someone who enjoys falling asleep beneath impossible questions. And for now, let your thoughts drift along those invisible rivers of gravity, flowing silently through a universe whose greatest structures were built not by force, but by patience. 13. What the universe looked like before galaxies. There was a time when the universe had no stars, no galaxies, no planets, no glowing nebulae drifting through space, no constellations decorating the night sky, no suns rising over distant horizons, no light-filled spiral galaxies spinning gracefully through the darkness. If you could somehow travel back far enough, beyond the birth of the Milky Way, beyond the formation of the first stars, beyond everything familiar, you would arrive in a universe almost unrecognizable. A universe waiting, a universe preparing, a universe filled with possibility, but not yet illuminated by it. Tonight we journey into one of the most mysterious eras in cosmic history, a time before galaxies existed, a time when darkness ruled everything, and when the first light of creation had not yet arrived. It may seem strange to imagine a universe without stars. After all, stars dominate our understanding of the cosmos. They forge elements, they create planets, they power galaxies, they provide the light by which we explore reality itself. Yet for hundreds of millions of years after the Big Bang, no stars existed anywhere, not one. The universe was dark, not empty, but dark. To understand why, we must travel back nearly 13.8 billion years. The universe began in an incredibly hot and dense state. In its earliest moments, temperatures were so extreme that atoms could not exist. Matter and energy formed a turbulent sea of particles. Light itself struggled to travel freely. Every photon was constantly scattered by charged particles. The cosmos resembled a glowing fog, brilliant, chaotic, opaque. Then, about 380,000 years after the Big Bang, something remarkable happened. The universe cooled enough for electrons and protons to combine into neutral hydrogen atoms. Suddenly, light could travel. The cosmic fog lifted. The universe became transparent. This ancient light still exists today. We call it the cosmic microwave background. It is the oldest light we can see, a fossil glow from a time before stars, a photograph of the infant universe. Yet even after the universe became transparent, stars still did not exist. The light from the cosmic microwave background slowly faded. Expansion stretched it, cooling transformed it, and eventually darkness settled across the cosmos. Astronomers call this period the cosmic dark ages. It's one of the most fascinating chapters in the story of existence. Imagine floating through space during this era. You would find yourself surrounded by enormous clouds of hydrogen and helium. The ingredients for future stars already existed. The raw materials of galaxies were present, but nothing had ignited yet. No stellar furnaces burned, no galaxies glowed, no planets circled distant suns. The universe was filled with invisible matter drifting through darkness. In some ways, it was a simpler cosmos, a quieter cosmos. The great structures we know today had not yet emerged. The cosmic dark ages lasted for tens of millions of years, possibly more than 100 million years, depending on where you looked. And during that immense span of time, gravity continued its patient work. Tiny differences in density existed throughout space. Some regions contained slightly more matter than others. The differences were astonishingly small. Yet gravity notices everything. Regions containing slightly more matter attracted even more matter. Clouds slowly grew denser. Hydrogen gathered. Gravity pulled. Time passed. Millions of years slipped by, then tens of millions. Eventually, some regions became dense enough to collapse under their own gravity. The first stars were born. And what extraordinary stars they were. These were not ordinary stars like our sun. The first generation of stars, known as population 3 stars, likely dwarfed anything commonly seen today. Some may have contained hundreds of times the sun's mass. They burned incredibly hot, incredibly bright, and incredibly fast. After millions of years of darkness, the first stars suddenly illuminated the universe. Imagine how dramatic that transition must have been. For countless ages, space had remained dark and silent. Then, one by one, distant beacons began appearing. The first cosmic dawn had arrived. Light returned to the universe. Those first stars transformed everything. Their intense radiation spread through surrounding space. Hydrogen atoms became ionized once again. The darkness slowly retreated. Astronomers call this process reionization. The universe was awakening. The first stars acted like cosmic lighthouses, piercing an endless night. And yet, we have never directly observed these earliest stars. They lived fast. They died young. Most vanished long ago. Their existence survives primarily through theory and indirect evidence. Like footprints preserved in ancient stone. We know they were there because we see what they left behind. When these colossal stars died, they exploded as powerful supernovae. Those explosions created heavier elements: carbon, oxygen, silicon, iron, elements that did not exist before. The first stars became the universe's first alchemists, transforming simple hydrogen and helium into the ingredients needed for planets and life. Without them, Earth could never have formed. Without them, neither could we. In a very real sense, every atom inside your body traces its ancestry back to these ancient pioneers. The first stars lit the darkness, and their deaths made complexity possible. As more stars formed, small groups began gathering together. Gravity continued organizing matter into larger structures. Proto-galaxies emerged, tiny compared to modern galaxies, chaotic, irregular, still growing, still evolving. These early galaxies collided frequently, merged repeatedly. Over hundreds of millions and then billions of years, they gradually transformed into the magnificent galactic cities we see today. The Milky Way itself began as countless smaller structures. Its story started during these ancient times, long before the sun existed, long before Earth formed, long before life appeared. There is something profoundly humbling about imagining this era. Today, we live in a universe crowded with stars. Our galaxy alone contains hundreds of billions of them. Across the observable universe, there may be trillions of galaxies. The night sky seems rich with light, yet all of it emerged from a period when none of it existed. Everything we see today was once merely potential, waiting, preparing, gathering. The stars had not yet ignited. The galaxies had not yet assembled. The future remained unwritten. And perhaps that is one of the most beautiful lessons hidden within the cosmic dark ages. Darkness was not the end. It was the beginning. The absence of stars did not mean the universe was empty of possibility. Quite the opposite. The darkness contained everything that would come later. Galaxies, planets, oceans, mountains, living creatures, dreams, questions, even the curiosity that allows us to wonder about these ancient times. All of it existed in seed form within that early darkness, waiting for gravity, waiting for time, waiting for light. As we drift toward the end of tonight's journey, imagine standing within that primordial universe. No galaxies illuminate the horizon. No stars shine above. Only vast clouds of hydrogen stretching endlessly through space. Quiet, patient, undisturbed. And somewhere in that immense darkness, gravity is already at work. Invisible currents slowly gathering matter together, preparing the first stars, preparing the first galaxies, preparing the universe we would someday call home. The darkness does not last forever. It never does. Eventually, the first lights appear, one after another, tiny points of brilliance emerging from an ocean of night. And from those first stars, everything else begins, including us. The universe we know today was born from darkness waiting for light. And perhaps that makes every star in the sky feel just a little more precious. A reminder that even the brightest cosmos once began in silence, patience, and the promise of a dawn still waiting to arrive. 14. The hidden lives of black holes. When most people imagine a black hole, they picture violence, a cosmic monster, a bottomless mouth devouring everything that comes too close, stars torn apart, planets swallowed whole, light itself trapped forever. And while there is some truth to those images, they tell only a small part of the story. Because black holes are not constantly consuming everything around them. Most of the time, they are surprisingly quiet, surprisingly patient, and in many ways far stranger than the monsters we imagine. Tonight, let's move beyond the popular image of black holes and explore their hidden lives, not as cosmic destroyers, but as some of the most mysterious and subtle objects in the universe. The story begins with a misconception. Many people imagine black holes as giant cosmic vacuum cleaners, objects that actively pull everything toward them. But if the sun were magically replaced by a black hole of exactly the same mass, something surprising would happen. Earth would continue orbiting almost exactly as it does now. The seasons would disappear because the sun's light would be gone. The world would quickly freeze, but Earth's orbit would remain largely unchanged. Gravity depends on mass, not on whether that mass is a star or a black hole. In fact, if you are far enough away, a black hole behaves remarkably normally. Its gravity follows the same rules as any other object. The true weirdness only begins when you get close, very close, near a boundary known as the event horizon. The event horizon is often described as the point of no return. Cross it and escape becomes impossible. Not because something physically grabs you, not because a force suddenly appears, but because space-time itself becomes distorted in a way that all possible paths lead inward. Imagine standing beside a waterfall in a river. Far upstream, you can swim against the current. Closer to the waterfall, the current grows stronger. Eventually, you reach a point where no matter how fast you swim, escape is impossible. The event horizon is something like that, except the river is space-time itself, and the waterfall leads somewhere no one can fully describe. What happens beyond the event horizon remains one of the greatest mysteries in physics. Our equations work beautifully outside, but inside, they begin to fail. At the center of a black hole lies what we call a singularity, a place where density appears to become infinite, a place where our current understanding of reality breaks down. Yet many physicists suspect singularities may not truly exist. Instead, they may simply mark the limits of our theories, a signpost telling us that deeper physics remains undiscovered. Black holes may be hiding secrets far beyond anything we currently understand. And perhaps even more surprising is the fact that black holes spend most of their lives doing almost nothing at all. The dramatic images we often see, stars being shredded, matter spiraling inward, enormous jets blasting across space, are relatively rare events. Most black holes are quiet, dormant, invisible. They wander through galaxies unnoticed. A stellar mass black hole drifting through interstellar space may spend millions of years without consuming anything significant. It simply exists, silent, dark, hidden among the stars. Even the supermassive black hole at the center of our own galaxy is surprisingly calm. Known as Sagittarius A star, it contains roughly 4 million times the mass of the Sun. Yet compared to the gigantic active black holes seen in some distant galaxies, it is almost peaceful. At this very moment, Sagittarius A star is largely resting, not feeding aggressively, not producing spectacular outbursts, just sitting quietly at the center of the Milky Way, a sleeping giant. But black holes have another hidden life that is even stranger. According to quantum physics, black holes are not completely black. In the 1970s, physicist Stephen Hawking discovered something remarkable. Quantum effects near the event horizon should allow black holes to slowly emit radiation. Today we call this Hawking radiation. The process is extraordinarily slow. For large black holes, the radiation is incredibly weak. No telescope has directly observed it yet. But if the theory is correct, black holes are not eternal. They gradually lose energy. They slowly evaporate. Over immense spans of time, they shrink, and eventually they disappear. This realization transformed how scientists think about black holes. For decades, black holes seemed like ultimate endpoints, objects that lasted forever. Now they appear to have lifespans, births, ages, deaths. Even black holes are temporary. The timescales involved, however, are almost impossible to comprehend. A stellar mass black hole may survive for around 10 to the power of 67 years. A supermassive black hole could persist for 10 to the power of 100 years or more. These numbers are so vast that all of recorded human history becomes less than a microscopic instant by comparison. The stars will die first. Galaxies will fade. New stars will cease forming. Yet black holes may continue existing long after almost every visible light in the universe has gone dark. In a sense, black holes may become the final great inhabitants of the cosmos, the last survivors of stellar history, the final monuments to an age of light. Imagine the universe trillions upon trillions of years from now. The familiar galaxies have changed beyond recognition. Most stars have already burned out. The sky is darker than anything we can imagine today, and scattered throughout that darkness remain countless black holes. Ancient relics, silent remnants of a younger cosmos, patiently wading through epochs so vast that language struggles to describe them. Yet even they cannot last forever. Eventually, Hawking radiation wins. Slowly, incredibly slowly, but inevitably. Each black hole begins losing mass. At first, the process is almost imperceptible. Then, over unimaginable timescales, it accelerates. The black hole shrinks, warms, radiates more energy. Finally, after a lifespan longer than almost any other object in existence, it vanishes. The last black holes may mark the final chapter of the universe's visible story. And perhaps the most fascinating question remains unanswered. What happens to the information that falls inside? Imagine dropping a book into a black hole. Every word, every sentence, every detail. What becomes of that information? Quantum mechanics says information cannot truly be destroyed, yet black holes seem capable of erasing it. This puzzle, known as the black hole information paradox, has challenged physicists for decades. Some of the greatest minds in science have devoted years to solving it. And despite significant progress, no complete answer exists. Some theories suggest information is encoded on the event horizon itself. Others propose it escapes through Hawking radiation. Still others hint that space-time may possess hidden structures we do not yet understand. The truth remains uncertain. Black holes continue guarding their secrets. Perhaps that is what makes them so captivating. Not merely their power, not merely their size, but their mystery. They sit at the crossroads of gravity, quantum physics, space, and time. Every attempt to understand them reveals deeper questions. The closer we look, the stranger they become. Far from being simple cosmic monsters, black holes may be among the universe's most profound teachers. They expose the limits of our knowledge. They challenge our assumptions about reality. They force us to confront questions that have no easy answers. And as you drift deeper into tonight's cosmic journey, imagine those countless hidden black holes scattered throughout the universe. Most invisible, most silent, most patiently waiting in the darkness. Not devouring everything around them, not raging with violence, simply existing, quiet guardians of mysteries we have yet to solve. Ancient objects carrying secrets from the birth of stars to the distant future of the cosmos. And somewhere beyond the edge of our understanding, perhaps black holes are not merely the end of something. Perhaps they are the doorway to questions we have not yet learned how to ask. For now, they remain among the quietest inhabitants of the universe, and also among its most fascinating. 15. The future night sky of Earth. Look up at the night sky tonight. The stars above you may seem permanent, timeless, unchanging. The same celestial patterns that guided ancient sailors, inspired early astronomers, and filled countless generations with wonder appear so stable that it is easy to believe they will remain forever. But they won't. The sky you know is temporary. Every constellation, every bright star, every familiar pattern, all of it is slowly changing. Not over days, not over years, but over millions and billions of years. The future night sky of Earth will look profoundly different from the one we see today. And if we could somehow travel forward through time, watching the heavens evolve, we would witness one of the most beautiful and humbling transformations in the history of the cosmos. Because the sky itself is alive. The stars are moving, the galaxy is evolving, and the universe never stands still. At first glance, the stars appear fixed. Night after night, Orion rises. The Big Dipper circles overhead. Scorpius stretches across the summer sky. The constellations seem frozen in place. Yet this is an illusion created by human lifetimes. The stars are not standing still. Every one of them is moving through space. Some travel toward us, others move away. Some drift sideways through the galaxy at enormous speeds. The reason we do not notice is simple. The distances are so immense that meaningful changes require thousands or millions of years to become obvious. Imagine taking a photograph of a mountain, then taking another one a second later. The mountain appears unchanged, but that does not mean geological forces have stopped. Likewise, the stars appear motionless because we are observing them over very short timescales. Given enough time, entire constellations begin to distort. The familiar sky starts rearranging itself. If future humans could compare the night sky 100,000 years from now with the one we know today, many constellations would already look noticeably different. Orion's famous shape would begin stretching. The Big Dipper would slowly transform. Ancient celestial landmarks would become unfamiliar. The sky would remain beautiful, but it would no longer be our sky. And some changes will happen even sooner. One of the most dramatic involves a star called Gliese 710. Currently located dozens of light years away, this star is moving toward our region of space. In roughly 1.3 million years, it may pass relatively close to the solar system. Not close enough to threaten Earth directly, but close enough to disturb distant icy bodies in the Oort cloud. The encounter could send comets drifting toward the inner solar system for millions of years. Future skies might occasionally feature spectacular comet displays, unlike anything humans have witnessed in recorded history. Imagine civilizations millions of years from now watching brilliant comets streak across the heavens, not knowing that the cause began with a stellar visitor passing nearby long ago. As millions of years become tens of millions, even larger transformations occur. Entire stars disappear, new stars appear. Some of today's brightest stars will already be gone. Take Betelgeuse, for example. The famous red giant in Orion's shoulder is nearing the end of its life. Astronomically speaking, nearing could mean tomorrow, or 100,000 years from now. Either way, Betelgeuse will eventually explode as a supernova. For a brief period, it may shine brighter than the moon, visible even during daylight. Then it will fade. Future generations will inherit an Orion missing one of its brightest stars. The constellation will never look the same again. Elsewhere in the galaxy, new stars are being born. Massive clouds of gas continue collapsing under gravity. Stellar nurseries quietly create future suns. Over millions of years, fresh stars will emerge to replace those that die. The galaxy constantly renews itself, like a cosmic forest where ancient trees fall and new ones grow. Yet perhaps the most spectacular transformation lies farther ahead, far beyond the lifespan of any civilization alive today. Several billion years from now, a remarkable event will begin unfolding in Earth's sky: the approach of the Andromeda Galaxy. Right now, the Andromeda Galaxy appears as a faint smudge visible under dark skies. It is beautiful, but subtle. Most people never notice it without knowing exactly where to look. Yet Andromeda is enormous, containing perhaps 1 trillion stars, and it is moving toward us at roughly 110 kilometers per second. The collision between the Milky Way and Andromeda has already begun. We simply happen to live during its earliest stages. Over billions of years, Andromeda will grow larger and larger in the sky. Future observers on Earth may eventually see it stretching across enormous portions of the heavens, a gigantic river of starlight dominating the night. The sight would be breathtaking. Imagine a spiral galaxy so large that its structure becomes visible to the naked eye, its glowing arms arching across the sky, its bright core shining like a second celestial landmark, night after night, year after year, growing ever closer. Then, around 4 to 5 billion years from now, the two galaxies will begin merging. Contrary to what science fiction often portrays, individual stars are unlikely to collide. The distances between them are simply too vast. Instead, gravity will slowly reshape both galaxies. Long streams of stars will stretch across the heavens. The night sky may become filled with brilliant stellar rivers. Massive star-forming regions could ignite. New constellations would emerge. Old ones would vanish forever. For millions of years, Earth could witness one of the greatest celestial spectacles imaginable: an entire galactic merger unfolding overhead. Yet by then, Earth itself faces another challenge: the Sun. Our star is middle-aged today, stable, reliable, comfortably converting hydrogen into helium. But this peaceful phase cannot last forever. In approximately 5 billion years, the Sun will begin transforming into a red giant. As its core changes, its outer layers will expand. The Sun will grow larger, brighter, hotter. The consequences for Earth will be profound. Long before the Sun physically reaches Earth's orbit, rising temperatures may render the planet uninhabitable. The oceans could evaporate. The atmosphere could change dramatically. Life, if it still exists, may need to adapt or migrate elsewhere. And the sky itself would transform. Imagine a sun that appears vastly larger than today's, a swollen red star dominating the heavens. Daylight would change, sunsets would change, even the colors of the sky might evolve. The familiar yellow-white sun would become something entirely different. Eventually, after shedding its outer layers, the sun will leave behind a white dwarf, a small, dense stellar ember. The future night sky would lose its central star. If Earth somehow survived, it would orbit a faint stellar remnant rather than a blazing sun. The solar system would enter a quieter chapter. But even that is not the end. Trillions of years from now, most stars throughout the universe will have exhausted their fuel. The age of star formation will gradually end. Galaxies will grow darker. The night sky will become less crowded, less brilliant, more silent. Future observers living in those unimaginably distant eras might look upward and see only scattered remnants of what was once a vibrant cosmos. Many galaxies will have disappeared beyond the observable horizon due to cosmic expansion. The universe will appear lonelier than it does today. In a strange way, we may live during one of the best eras to observe the cosmos. We can see countless galaxies. We can study stellar birth and death. We can witness a universe rich with activity. Future civilizations may not be so fortunate. the cosmos they inherit could be far darker, far emptier, far more isolated. And yet, there is something comforting about this constant change. The sky is not a static painting. It is a story written across billions of years. Every star has a beginning. Every constellation has a lifespan. Every galaxy evolves. The heavens above us are part of an ongoing journey, a journey that started long before humanity appeared and will continue long after we are gone. So tonight, as you look up at the familiar stars, remember that you are seeing a temporary masterpiece, a unique moment in cosmic history. The exact arrangement of lights above your head has never existed before and will never exist again. The future sky will belong to different stars, different galaxies, different wonders, but it will remain what it has always been, a reminder that the universe is alive, forever changing, forever unfolding, and forever inviting us to wonder what the next night will bring. 16. When the universe forgets the stars. There is something strangely comforting about the stars. For thousands of years, they have watched over every human story, every civilization, every dream, every question whispered into the darkness. Long before cities existed, people looked upward and found the same brilliant sky. The stars became maps, calendars, legends, companions during lonely nights. They appeared eternal, unchanging, permanent. Yet even the stars belong to an age that will not last forever. Tonight, we arrive at one of the most distant chapters in the story of the universe. A future so unimaginably remote that every mountain on Earth, every ocean, every civilization, every galaxy we recognize today will have faded into history. A future when the universe itself may begin to forget the stars, not because the stars were never there, but because nearly all traces of their existence will slowly disappear. To understand this future, imagine the universe as a great cosmic city, illuminated by countless lights. For billions of years, new stars have been forming. Gas clouds collapse, gravity gathers matter, nuclear fusion ignites, and darkness fills with light. The universe we know today exists during this brilliant era. Astronomers sometimes call it the stelliferous era, the age of stars. It is a remarkably fortunate time to be alive. Across the cosmos, hundreds of billions of galaxies glow with stellar activity. New stars continue to form. Supernovae enrich space with heavy elements. Planets emerge. Life becomes possible. The universe feels vibrant, alive, full of possibility. Yet even now, the end of this age has already begun. Every star shines by consuming fuel. Hydrogen becomes helium. Helium becomes heavier elements. Eventually, the fuel runs low. Every star must confront the same reality. Its light cannot last forever. Massive stars burn quickly. Smaller stars burn slowly. But all of them are living on borrowed time. The universe possesses a finite supply of star-making material. And once that material is exhausted, something profound happens. The creation of new stars begins to slow, then slows even more, until eventually it almost stops altogether. Imagine looking into a future trillions of years from now. The giant stellar nurseries that once filled galaxies have largely disappeared. Most available hydrogen has already been consumed. The brilliant birthplaces of stars have grown quiet. Galaxies that once sparkled with newborn suns now contain aging stellar populations. The cosmos becomes older, calmer, dimmer. The great stellar factories shut down one by one. And gradually, the universe enters a long twilight. At first, there are still stars, many stars, particularly red dwarfs. These small stars are remarkable survivors. Unlike massive stars that burn brightly and die quickly, red dwarfs conserve their fuel with extraordinary efficiency. Some may continue shining for trillions of years, far longer than the current age of the universe. If future civilizations exist in these distant eras, red dwarfs may become their primary suns, the last reliable beacons of starlight. But even these cosmic misers cannot shine forever. Given enough time, even the longest-lived red dwarfs eventually exhaust their fuel. One by one, the final stars fade. The age of stellar light slowly comes to an end. And when the last true stars disappear, the universe changes in a way almost impossible to imagine. For the first time since the earliest cosmic dawn, there are no new suns waiting to rise, no future constellations waiting to form, no stellar dawns awaiting distant worlds. The sky enters a darkness deeper than anything humanity has ever known. But the story does not end there, because dead stars leave behind remnants. White dwarfs, neutron stars, black holes, ghostly monuments to a brighter age. White dwarfs may dominate much of the future cosmos. These dense stellar embers contain the remains of stars like our sun. At first, they remain hot, glowing softly, but over trillions of years, they cool. Gradually, patiently, their light weakens, their warmth fades. Eventually, they become theoretical objects known as black dwarfs, cold stellar corpses drifting through space. Interestingly, the universe is not yet old enough for a single black dwarf to exist. Not one. The cosmos is still far too young. Black dwarfs belong entirely to the future, to eras beyond anything humanity will ever witness. Imagine a universe populated by countless invisible black dwarfs, the skeletal remains of once brilliant stars, a vast graveyard of extinguished suns, the universe remembering light only through relics. Neutron stars also continue their long existence. These incredibly dense objects contain more mass than the sun, compressed into a sphere only about 20 kilometers across. They spin, they cool, they age. Yet even they slowly lose energy. The vibrant universe that created them becomes increasingly difficult to recognize. And then there are the black holes, perhaps the greatest survivors of all. Throughout cosmic history, black holes quietly accumulate. The deaths of massive stars create them. Galactic mergers create larger ones. Entire galaxies become organized around enormous, supermassive black holes. As stars disappear, black holes increasingly dominate the future universe. In a strange way, the age after stars may become the age of black holes. For incomprehensibly long periods, they persist. Long after galaxies have faded, long after stellar remnants have cooled, long after nearly every visible source of light has vanished, black holes remain. Silent, patient, ancient. Yet even they cannot survive forever. As we explored earlier, black holes slowly evaporate through Hawking radiation. The process is unbelievably slow. A supermassive black hole may require 10 to the power of 100 years or more to disappear. That number is so enormous it barely fits within human intuition. But eventually, even these giants reach their end. The final black holes evaporate, one by one. The last great monuments of the stellar universe vanish, and with them disappears one of the final reminders that stars ever existed at all. Imagine standing in that future, not millions of years ahead, not billions, not trillions, but vastly beyond even those numbers. The galaxies are gone, the stars are gone, the black holes are gone. The sky contains no familiar landmarks, no glowing constellations, no bright galaxies, no stellar rivers stretching across the heavens, only darkness and scattered particles drifting through an increasingly empty cosmos. This is sometimes called the Dark Era, a future so distant that the entire history of stars becomes a brief opening chapter in the universe's story. What is perhaps most fascinating is that future observers, if any could exist, might struggle to reconstruct what came before. Evidence erodes, structures decay, information disperses. The universe slowly loses memory of its younger self. The brilliant stellar age that once filled space with light may become nearly impossible to detect. In a sense, the universe begins forgetting the stars. Not intentionally, not consciously, but through the relentless passage of time. The same way footprints disappear from sand, the same way mountains erode, the same way memories fade. And yet, there is something beautiful about this ending, because it reminds us how special our moment truly is. We live during the age of stars, a brief but extraordinary chapter. We can see galaxies. We can watch stars being born. We can study nebulae glowing across space. We can witness supernova explosions. We can trace the history of cosmic evolution. We exist during a rare interval when the universe is illuminated, when the story of the stars is still being written. And perhaps that makes tonight's sky even more precious. Every star overhead represents a temporary miracle. Every point of light belongs to a chapter that will not last forever. The heavens above us are not permanent monuments. They are fleeting visitors, beautiful because they are temporary, meaningful because they are fragile. And as the universe continues its endless journey into the future, the stars will eventually fade. The galaxies will eventually dim. The great stellar age will eventually pass. But tonight, they are still here, shining above oceans, above mountains, above sleeping cities, above everyone who pauses long enough to look upward and wonder. And perhaps that is enough. Perhaps the true beauty of the cosmos is not that it lasts forever, but that for a little while, in this brief, luminous chapter of cosmic history, the universe learned how to shine. Thank you for joining me on this quiet journey through the hidden universe. As the night grows still, let these forgotten worlds, ancient lights, and silent cosmic structures drift gently through your thoughts. Rest peacefully, and I'll meet you again on another voyage through the mysteries of the cosmos.